And welcome to lesson 3. So far in this course we've covered speed and velocity. Speed is a scalar, velocity is a vector. We've looked at the two acceleration equations, v minus u over t, and the constant acceleration equation, v squared minus u squared equals 2as. Today we're going to do something a bit different. We're going to look at graphing both speed and acceleration. So it's a two-part lesson. First part of the lesson we're going to look at graphing speed, which you should have had experience with in year 9. So for a speed equation graph, the two things we're going to have on our axes is time along the bottom and distance or displacement up the side. So I'm just going to put distance. It doesn't matter in this case. We're going to measure that in meters, could be in kilometers, could be tens, could be 50s, could be hundreds, it's up to you. But I'm going to keep it simple. And to show you how it works, I'm going to plot this journey. So I'm going to plot 5 separate points. I'm going to go 4 meters in 2 seconds. So let's choose a nice bright colour. So I'm going to go 4 meters up, I'm going to go 2 meters across, and I'm going to put a cross there. And I'm going to do something we tell you not to do. I'm going to do dot to dot. And I'm going to label this number 1. There it is. Next, you then stand still for 2 seconds. So we go 2 seconds across, still at 4, because I haven't moved. So I go across, and I can write a 2 there. Next, I go 6 meters in 1 second. Now I've already gone 4, so 6 more puts me up at 10. And I've done that in 1 second of time. So I bring it to this point here. I'll write a number 3. Next, we stand still for 3 seconds, which puts me 3 seconds across. Across there, that's number 4. And finally, we go home in 10 seconds. Now, home is the origin. You can think of this as the beginning of your front door, and then you walk away, the distance increases. So if you go home, you go backwards. So if I shrink that back, and I go from there to there, and that is number 5. Now, the thing you'll notice is the gradient all around this graph changes, and we can actually link the gradient, so copy this in, gradient is the speed. Because if we were to take the speed equation, I'm going to go over to orange. If we were to take the speed equation, speed equals distance over time. And if we look at this, we have distance in this axis. I'm going to make this thicker. Let's go with that one. We have a distance here. We have a time here. And from mathematics, the gradient of a line, the gradient is y divided by x. So in this case, y is the distance, x is the time. And if we were to do it this way, we'd end up with speed is distance over time. So the gradient is the speed. And so we can work out for each point, 1, 2, 3, 4, 5, the speed that we're going. So let's take the first one. I'm going to go back over to purple. We go 4 meters in 2 seconds. So we have a change. Let's just plot it here. We have a change of 2 seconds and 4. So the gradient is 4 over 2 meters per second. Next, part 2. There is no gradient. It's flat. There is no y. So it's 0 divided by 2. So in this case, the speed is 0. Next, we go 6 meters in 1 second. So we take the gradient. Nice and easy, this one. We have y-axis of 6, x-axis of 1. 6 over 1 equals 6 meters per second. Then we have standing still, so speed equals 0. And then finally, a little bit trickier, we have a negative. We have decreased by 10. So we have 10 over 2, 10, but we have minus 10 over 2. So we're going minus 5 meters per second. And if you remember from the first lesson, we can show minuses for speeds because then they become velocities. and it gives us an idea then of what is going on with the speeds. So that is graphing speed in a nutshell. My advice is to copy this one down, plot it all out, work it out yourself as you go, and then cross-reference that what's written in the textbook, which I'll attach. Right, the next one, a little bit trickier, acceleration. So we're going to plot again a route. Now this time, the axes of an acceleration graph are time, again at the bottom, time in seconds, but up the side this time it is velocity. It's not distance. So velocity in meters per second. So similar kind of thing. Let's plot a route. I'm going to call them A, B, C so my numbers don't get in the way. So let's say from rest, so you're not moving, up to 4 meters per second in 2 seconds. B, stay at 4 meters. Oh wow, I'm rushing. 4 meters per second for 3 seconds. C, up to let's say 10 meters per second in 2 seconds. D, stay at a steady speed for, let me check this, 2, 5, 6, 7, 1 second. And finally E, stop in 2 seconds. Now what some of you may have noticed is working out, let me highlight them, the time. I don't want to go over 10, so I'm doing 10 plus 3 is 5, plus 2 is 7, plus 1 is 8, 9, 10. And the biggest velocity I'll put on here is 10. That means I don't go through the axes, go off the sides. So let's plot it, see what it looks like. I'm going to go back to red, put a chunkier pen. So we go from rest up to 4 meters per second in 2 seconds. Let's try that again. So it will be there. Same thing, I'm going to join it up. I'm going to make sure I write on the outside. There's a very important reason for that, and I'll show you later. Next, I'm going to go stay at 4 for 3 seconds. So I'm going to go 3 seconds across. I'm going to put my line, and I'm going to put B. Next, I'm going to go up to 10 meters a second in 2 seconds. So I'm going to go up. Similar to my old one, a little bit of a change towards the end. I'm going to stay at a steady speed, so I'm going to stay at 10. D. And then I'm going to stop, so 0 in 2 seconds. And I'm going to call that E. Remember, right on the outside, there's something I'm going to show you about the inside in a minute. So what do we see this time? Well, just like last time, where the gradient was the speed, what do you think this time the gradient of this will be? And if you said acceleration, you are correct. We get acceleration is v minus u over t. So what does that mean? Well, there is v, there is u, the beginning of the line, the end of the line. So this distance here is y. This distance across is x. Gradient, the gradient of a line, mathematically you would write it as m from y equals mx plus c. Well, we ain't got c, so gradient is m in maths. Don't want to confuse matters. So the gradient would be, in this case, 4 minus 0 over 2. That'd be the acceleration of 2 meters per second squared. So that's the first one. Let's look at the others. choose a smaller pen. Here we've got no gradient, so B has an acceleration of 0. This one was 2 meters per second squared. Right, C. We're going to start and we're going to go across here. Let's do it a bit bigger. There we go. We're going to go from there to there. V was 10. U was 4. So to work it out, we're going to do 10 minus 4, which is 6, over 2 seconds gives us 3 meters per second squared. Steady speed, acceleration equals 0. And the final one, what kind of number are we going to get? Positive or negative, I wonder? It's going to be negative, because this time round, U is the beginning, V is the end. So this time we have V is 0 here. I know I've circled the 10, but that's not it. 0 meters per second minus 10 meters per second over 2 seconds gives me minus 5 meters per second squared. So that is how we use a velocity time graph to find acceleration. Now, you remember I said don't draw inside. I mean, I have, but I've got a rubber. Haha. There's one last thing I want you to finish with, and it's a really nice little fact that will gain you some extra points. And it's this. If I wanted to know how far I've been on this graph, all I need to know is the area underneath the graph. If I could count all the squares, that is how many meters I've gone. So I'll say that again. The area under a velocity time graph is the total distance travelled. So in this case, it would be how many meters I've gone, because that's what I'm using in my y and x axis, my y-axis. So there it is. If I could find that area, I'm sorted. Now, how am I going to find the area of that complex shape? Well, I'm going to get old school. I'm going to chop it up. I'm going to have a triangle there. I'm going to have a square there. In fact, I'm going to cheat. I'm going to go rectangle there, like so. And then I'm going to do that. And there are millions of ways of chopping this up. There's probably a far better way than this, but my brain's not working properly. There we go. And I could take that out. Didn't mean to do that. I want to just hit that. Oh, it won't work. One more go. See if I can make the rubber really tiny. Just that line there. Nope, you're going to take it all with it. Poo. Okay, so let's have a look. What do we get? So the first one, 2 times 4 is 8, divided by 2 for its triangle is 4. And then here we've got 1, 2, 3, 4 times 1, 2, 3, 4, 5, 6. Ignore that. 4 6s, 24. Here I've got 1, 2, 3, 4, 5, 6, so I can write the 6 in. Here I've got 2 times 6 divided by 2 is 6. And here I've got 10 times 2, which is 20, divided by 2 is 10. So then we just write them out. So we're jumping all over the place. I'm just going to wipe this stuff out so I've got room underneath. There we go. So we have 6 add 24 add. God, tell me I'm not a maths teacher. Add that 4, add the 10, add another 6. No pressure. Here we go. I'm going to take those two together. That gives me 30. Those two together gives me another 10 plus another 10, and it gives me, I believe, 50 meters. So let me repeat one more time. The area under the velocity time graph is the distance travelled. You chop it up into triangles and squares, add it all together, that's the distance. So that's my final thing to write today. The area under a velocity time graph is the distance travelled. Full stop. Get my highlighter out. Definitely key points area. Let's try and get rid of that random dot that froze on me. So the area under a velocity time graph is the distance travelled. Really key to it. And that's it. Give it a go. Look at the notes. Answer the questions. Bye bye.